Okay, we are going to do set 8 today for Thursday. We're going to start with number 1, and it is simplify the expression. So we're going to use our order of operations, so we're going to use our PEMDAS. Remember, anytime we see order of operations, we want to write our PEMDAS, we want to put our multiplication and division in a box, our addition and subtraction in a box, and that reminds us that we do these have equal value, so we do them from left to right, no matter how they appear. So if division actually comes before multiplication in our PEMDAS, then we know that we're going to do that first. Same with addition and subtraction. We're working left to right, okay? So you can put little arrows above here if you want to, just to remind yourself. We do these operations left to right, whichever one comes first. Okay, so we're looking at number 1. We do have parentheses. That's the first thing we look for. Our P stands for parentheses. So we're going to do our first set of parentheses first, and 7 plus 3 is 4. We bring down our subtraction sign. We bring down everything that we haven't used yet. We have a brand new expression. We go back to PEMDAS. Do we have parentheses? Yes, we do. So we're going to do those first. 3 times 2 is 6. We're done with what was in the parentheses, so we don't need to bring down the parentheses, but we do have to bring down everything else that's left. Oh, and why did I put, oh my gosh, I'm so sorry, guys. This is 10. I have no idea. I actually subtracted instead of added. I was like, wait, that's not going to work. Okay, it's a little early in the morning, sorry. So we have 10 because 7 plus 3 is not 4, it's 10. So we've got 10 minus 6, and 10 minus 6 is 4. Maybe that was what my brain was doing. It was already knew the answer. Okay, so we've worked our PEMDAS all the way down, and we got the answer 4. All right, number 2, we have 1/5 plus, we're going to say this. Remember, every decimal has a fraction, and every fraction has a decimal. We say that all the time in class. So we're going to say this. This decimal is 5/10. So we're going to write 5/10 as a fraction. So that way we can have the same kind of number that we're adding together. So remember, anytime we add, subtract fractions or mixed numbers, we write them vertically. Just makes it a little bit easier to find our common denominator, okay? We're going to circle our biggest denominator. That's what we do first every time. So that's going to be 10. Then we ask ourselves, does 5 go into 10 evenly? It does. So if you say yes, you've already got your common denominator. It's whatever number was circled, so you just write it for both. Remember, we can't add or subtract without common denominators. So how do we get from 10 to 10? Well, that's going to be times 1. Nothing changed. So that's going to be times 1. So we have a 5 here. Well, how do we get from 5 to 10? We multiplied by 2. So whatever we do on the bottom, we have to do on the top. So 1 times 2 is 2. We're adding only the numerators. So 5 plus 2 is 7. Our denominator stays the same. And then remember, we always have to ask ourselves, can we reduce this? Can we simplify 7/10? Well, I can hear y'all right now. I can hear Jamila. She's going, no, we can't because 7's prime and it's not a factor of 10. And that is correct. If you have a prime number as your numerator and it's not a factor of your denominator, then you know that you're done and you've reduced it lowest terms. All right, we're looking at number 3. It says draw a model, write an equation, and solve the problem. So y'all know I'm not going to make you draw a model because I hardly ever do, so we're just going to write the equation. All right, it says Kirsten bought 7 pounds of potatoes. Each pound cost 45 cents. Well, if you go to the store and you're buying 7 pounds of potatoes and each pound is 45 cents, we know we're going to multiply these two numbers together. Okay, we know each in this problem stands for multiplication. She paid the clerk $20. How much change did she get? So you go to the store, you've got $20, you go buy 7 pounds of potatoes, they cost 45 cents each, and it's saying how much change are you going to have left? Well, if we know that, if we're going to write our equation, then we're going to start with our whole, and our whole is $20. That's what we walk into the store with. Then we're going to buy our 7 pounds. Remember, we have to multiply this. We're going to buy our 7 pounds at 45 cents a piece, and that's going to equal our change, whatever we have left. Well, am I going to put a minus sign here or a plus sign? If you walk into the store with your $20 and you buy something, is that going to be subtracted from your $20 or added? Well, you know it's going to be subtracted, okay? So here's our equation that we have set up. So essentially, it's kind of a little mini PEMDAS. So we're going to write this here because I want y'all to be able to see me do it. Okay, so we've got 20 minus 7 times 45 cents, or 7 pounds. So we're going to go back to PEMDAS. Think about this. Do we have parentheses? Yes. So we've got 7 times 45 cents, so we're going to need to do that first. So we've got 45 times 7. Remember, I put the number with the most digits on the top when we're multiplying. 7 times 5 is 35, carry the 3. 7 times 4 is 28, 29, 30, 31. So do our potatoes cost $315? No, we know they don't. That's not even reasonable. So remember, we've got a decimal up here. We've got 2 place values past the decimal. So we write our little 2, and that tells us how many times we're moving our decimal back. Where's our decimal right now? It's at the end, okay? We're going to move it back twice, and that's telling us that we have $3, that we spent $3.15. Is that a reasonable answer? Yes, it is, okay? So we can come up here and write down that this equaled $3.15, and we have 20 minus 315. Didn't need to bring those parentheses down, sorry. We solved everything in the parentheses, so we don't really need those. So now I'm going to have to subtract. Well, if this is a 20 and it doesn't have a decimal, where is it? Well, the decimal's at the end, and really I took away those 2 zeros when I wrote it as an equation, but you could have kept it if you wanted. We know we have to line up decimals when we subtract. And again, we get to subtract the cool way. So 2 minus nothing is 2, but does our friend need help? Yes. So we're going to take 1 away from that and make that a 1 and give that extra help to our friend. 10 minus 3 is 7, but does our friend need help? Yes. So we're writing a 6, giving that extra help to our friend. 10 minus 1 is 9. Does our friend need help? Yes. So we're writing an 8, giving that extra 1 to our friend. And 10 minus 5 is 5. We bring our decimal straight down, and so our change, our answer to this is going to be $16.85. So I'm going to go ahead and do this here too. This was $3.15. 20 minus 315 ended up being $16.85. So that is what our change is. Okay, so C equals $16.85. Okay, so we are going to be doing some conversion, which is perfect because Penelope asked me to do conversion video and I haven't done that yet. So we'll do that here today. All right, so remember guys, when we are converting, the first thing you ask yourself is this metric conversion or is this US customary? Well, you know it's going to be metric if you've got liters, meters, or grams. If you've got milli, centa, deca, deci, any of that, that's going to be your, that's going to be metric. So if you see it's metric, the first thing you're going to do is King Henry died unexpectedly drinking chocolate milk. You're going to write your little cliche that helps us do this, okay? So in the 5th grade, we've got kilo. The U stands for unit of measure. So this is where our liters, our meter, and our gram is. This is our basic unit of measure. This is our centa, and this is our milli. And that's really all we use in the 5th grade. So when we're using this, we go back and we say, okay, what did it give us? It gave us 2 liters, and it's wanting us to convert that to milli. So we're going to write down the number that it gave us, and that's a 2. But we have to put our decimal on this number, and if it's not there, we know it's at the end because we know that's a whole number. Well, if this is representing liters, that's going to be our U, okay? So we know that we're starting at the U, and we're going to milli because it's saying milliliter. So we're going to go 1, 2, 3 to the right, okay? Each of these represents multiplying by 10 or dividing by 10. So we're going to move our decimal 3 times to the right, 1, 2, 3. And what are we going to need to put in here? We're going to need to put in zeros. So our 2 liters converted to 2,000 milliliters, which makes sense because a milliliter is teeny, 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 tiny, and a liter is going to be much bigger. So there's going to be lots more milliliters or millimeters or milligrams in a liter, a meter, or a gram. So that's why that number is going to be bigger. Okay, the next one is 60 inches into feet. Well, is that metric or is that US? Well, we know it's US, so that's when you can grab your little reference material and you can say, okay, We're talking inches to feet, so what's our original conversion? Our original conversion that we're given for feet to inches is right here. So as soon as you see that it's U.S. customary, remember that we write our shell. That's the first thing you do. If you know it's not metric, you can immediately draw the shell, and then you're going to go figure out, you're going to write what you're converting. We're converting inches to feet, okay? You go to your reference sheet, and we know that there's 12 inches in 1 foot. So there's 12 inches in 1 foot. When you write your original conversion, you're always going to have one of these is always going to be a 1, okay? So we are converting inches to feet. We go back to our problem and we say, okay, which one did it give us? Did it give us the feet or inches in our problem? Well, it gave us the inches, and it's 60. So we have to put that number beside whichever unit of measure it gave us. So this was 60 inches, so it has to be with the inches, okay? So this is where our original conversion comes off of this. This is what numbers come off of our problem, okay? So then we just do our arrow method, and y'all, you're super good at this. We do this all the time when we're making common denominators. How did we get from 12 to 60? Well, 12, 24, 36, 48, 60. So we did times 5. And remember, whatever we do on the top, yep, we have to do on the bottom. So 1 times 5 is 5. So if we're converting inches to feet, 60 inches converts to 5 feet. Again, think about that common sense. If we have little inches and we're turning that into feet, well, a foot is 12 inches, so this number is going to be less because this is a bigger unit of measure, okay? All right, so we look at the next problem, and it's gallons to cup. Well, is that U.S. customary or is that metric? Well, it's U.S. customary. So again, we immediately draw our shell. We go to our conversion. This is where we kind of look at our gallon guy. Our gallon guy is actually easier to do this, I think, than the conversions up here because you guys are really familiar with this. So we're looking for gallons to cups, so we can go ahead and write gallons to cups. Okay. Well, we know this is G. This is our big gallon. We know there's 4 quarts in a gallon. We know there's 2 pints in each quart, and those little tiny C's that you can see, there's a couple of cups. There's 2 cups in each pint. So if we're looking for how many cups are in the whole gallon, we're counting all the C's. So we can count by 2s. You ready? 2, 4, 6, 8, 10, 12, 14, 16. So there's 16 cups in 1 gallon. So we're going to write our conversion here. There's our 1. This is our regular normal conversion. And then we go back to our problem. Which one did it give us? Did it give us gallons or did it give us cups? It gave us gallons, so we're going to write that in the correct place. We're going to do our arrow method again. How do we get from 1 to 4? We multiplied by 4. Whatever we do on the top, we got to do on the bottom. So we're going to do 16 times 4. 4 times 6 is 24, carry the 2. 4 times 1 is 4 plus 2 is 6. So we know that our 4 gallons are going to convert to 64 cups, which again makes sense because cups is going to be a little cup and a gallon is like a gallon of milk. So there's going to be way more cups in a gallon. So this makes sense logically. Okay. All right. We look at the next problem. Is it US or is it metric? It's US again. So we're going to draw our shell. We are converting pounds to ounces. We always want to put our label first. We come over to our reference sheet. We're looking for pounds to ounces. Here it is right here. We have 1 pound equals 16 ounces. So we put that 1 pound equals 16 ounces. We put our original conversion here. We go back to our problem. They gave us 6, and that's with pounds. So it's going to go with our pounds. Again, how do we get from 1 to 6? Times 6. Whatever we did on the bottom, on the top, we have to do on the bottom. So we're going to multiply 16 times 6. So 6 times 6 is 36, carry the 3. 6 times 1 is 6, plus 3 is 9. And that means our 6 pounds converts to 93 ounces. And we are done. So remember, metric is King Henry died unexpectedly. US conversion is a shell, original conversion, and then figure out how to make it equivalent. All right, number 5 says use the table that we made yesterday for number 5 to write and solve a word problem. So here's our work that we did yesterday. Our number 5 was the stem and leaf, and we get to make up a problem. So remember, guys, when we were doing stem and leaf in class, the first thing you want to do is look at your key. Make sure you know if it's whole numbers or decimals. And then kind of think about what the questions were when we were doing stem and leaf. Most of the time it was, what's the range? What was the highest score? What was the lowest score? You know, things like that. So we're going to just make up a couple questions. Let's do range, because I know we talked about that a lot. So let's say, what is the range of scores? Okay, because these numbers represented scores. Sorry, that's really sloppy. What is the range of scores? Well, remember, hey diddle diddle, the median's the middle. You add then divide for the mean. The mode is the one that appears the most, and the range is the difference between. That poster is in your Google posters, but remember we sang that to hey diddle diddle. So the range is the difference between. It's always the difference between the least and the greatest, okay? So remember, when we're reading a stem and leaf, our least number is going to be the very first number that we have. So we have 4 and a 5, so that's going to be 45. And then our greatest number is our last stem and the very furthest number. Well, on this particular stem and leaf, we only had 76. Okay, so that's going to be our larger number. But I wrote this last night. So if we had a 7, an 8, and a 9 here, our biggest number would actually be 79, because it's the last stem, but it's the furthest away leaf that's our greatest number. Okay, so on this particular stem and leaf, the biggest number was 76. So if we're finding the range, and range is the difference between, difference means we are subtracting. So we have 76 minus 45, 7 minus 4 is 3, 6 minus 5 is 1. So what is the range of scores in our stem and leaf? The range is 31. Okay, let's also say, what is the mode? Because that was kind of fun for us to find. The mode is the one that appears the most. So when you're looking for mode, you're really just looking first at your leaves. Okay, so we have 3 5s, 1 7, we've got a couple 4s, we've got 3 1s, we've got 2 3s and 2 4s. So which one of these numbers appears the most? Well, we've got 3 5s and we have 3 1s. Except for our mode is not 5 and 1, because these 5s represent this number. These 5s represent 45, 45, and 45. So one of our modes is 45, and our other mode is 61. And it's okay that you have 2 modes, because sometimes you just do. Okay, so last one, we are going to multiply and divide, and we're going to do this pretty quick, since this video is kind of long. So we got 2 times 2 is 4, 2 times 3 is 6, 2 times 6 is 12. Cross that out, put your 0 placeholder. 4 times 2 is 8, 4 times 3 is 12, carry the 1, 6 times 4 is 24, plus 1 is 25. We're going to add all this together. We got a 4, 8 plus 6 is 14, carry the 1, 2 plus 2 is 4, plus 1 is 5, 5 plus 1 is 6, and 2 plus nothing is 2. Now, we got to look up here. We got 2 numbers with decimals. So we have 2 digits to the right of the decimal here, and we have 1 number to the right of the decimal here. So this is how many times we have to move back our decimal. So 2 plus 1 is 3. Our decimal is always at the end. So it's here. We're going to move it to the left 3 times. So our final answer is 26 and 544 thousandths. All right, we are dividing. Now, usually we round this, and if we were going to round it, we would put a 2, because 24 is closer to 20 than it is to 30. But y'all, this time I want you to think about this number. What could we do that we already know, we're already super familiar with, that's really, really close to this 24? What number is really close to 24 that you guys have worked with ever since you were little? 25, right? You know quarters are worth 25 cents, and that's really close to 25, right? So if we're thinking about money again, how many quarters would be in 85 cents? Well, 25, 50, 75, that's really close. So if you go 4 quarters, you know that's $1, and that's going to be way too much. So you already know that 24 goes into 85 3 times, because you know about money. Now, this isn't going to be 75 because this isn't a quarter. So we're going to have to go multiply 24 times 3. 4 times 3 is 12. Carry the 1. 6 plus 1 is 7. So this actually, 3 times 24 actually equals 72. Okay, we're going to subtract. 8 minus 7 is 1. Does our friend need help? No. So we put our 1. 5 minus 2 is 3. This is less than our divisor, so we bring down our 4. We're going to think money again, guys. If this is a quarter, we'd have 25, 50, 75, $1, $1.25. Well, if we had 6 quarters, that'd be $1.50. That's too much. So we know it's going to be 5. Again, oh my goodness, y'all, I forgot to float the bobber. I'm so sorry. Don't forget to do that first. So we know this is going to be a 5. So let's go ahead and multiply 24 times 5. 5 times 4 is 20. Carry the 2. 10 plus 2 is 12. So we've got 120. We're going to subtract. 3 minus 2 is 1. Does our friend need help? No. So we write our 1. 4 minus 0 is 4. It's less than our divisor, so we can bring down our next number. And we've got 144. Well, guys, if we know that 24 times 5 is 120, think about what we know this answer is going to be. If this is already 120, and we add 24 to this, or we can just quickly multiply it by the next number. 6 times 4 is 24, carry the 2. 12 plus 2 is 4. What'd we get? 144. Okay, great job.